we'll start already. Question 1 for the revision exercise. So here we have the heights of students in a class, just like students in our class, and we measure them. The results are summarized over here. Now the height, smaller than 120 cm. 120 cm quite short, right? So very few people are in fact 0. Who are you looking at? Huh? Who are you looking at? Okay, less than 130 cm, only 1. Okay, now next, we need to refresh our memory. Okay, Gao Jin, David, Ahmad, mask. Let's recap. These 8 people who have height less than or equal to 140 cm. No answer for that. These 8 people, they include this one person whose height is less than or equal to 130 cm. Okay, it includes this one is found inside the 8 over here. In the same manner, these 8 people, they are found inside these 12 people. Okay? They are part of the 12 people. Likewise, that's why you see the number getting bigger and bigger. So all 30 people are less than or equal to 180 cm. All 30 people are less than or equal to 180 cm. Now, find the number of students in the class. Straight away, the largest number. Part A, 30. 30 students in a class. It is not done by adding every single number up. But B, number of students height more than 150 cm. So more than 150 cm. We don't want the 12 over here because there are 12 who are less than or equal to 150. So number of students will be 30 minus 12. So we get 18. Next. Similarly, this is our cumulative frequency. Number of leaves with a length more than 6 cm. So clearly we must look at this value. X less than or equal to 6 cm. Now there are 15 of them. 15 of them less than or equal to 6 cm. I want more than 6 cm, so I don't want this 15 of them. So number minus 15, what is the total? Total is 40. So number of leaves be 40 minus 15. Now to complete the table. Yeah, just minus. So 3 of them between 4 and 5 cm. Next, between 4 and 5 cm, we have 3 of them. Now, between 5 and 6 cm, we have 12. So this makes up a total of 15, which is found here. So less than 6 cm includes 4 to 5 and 5 to 6. So that's where we get a 15. Same 15. Then when we talk about between 6 and 7 cm, we have to consider this value. 29 of them are less than 7 cm, less than or equal to. I only want those that are between 6 and 7, which means I do not want the 15. I don't want this. So 29 minus 15, we get 14. So same way, we got 10 and 1. Median value. To find a median, we need the median position. So the median position is found from the vertical axis. There are 80. So the position is divided by 2. 50%. So you get 40. This is the median position. But we want the value from there. So part A, median, 55 kg. Interquartile range. So interquartile range, we need to find the lower quartile position, upper quartile position. Then we get the values and we subtract. So part B, lower quartile position. That is our 25% times 80. So 1/4, that is 20. So lower quartile equals to, at 20, 48 kg. That's my lower quartile value. Then I need my upper quartile position, which is 75% times 80, that is 60. So find the value for 60. My value is 65. So upper quartile equals to 65 kg. Therefore, the interquartile range, 65 minus 48. What is this? 17. Okay, so that's my interquartile range, 17 kg. Finally, part C, 60th percentile. 60th percentile position. 60% times 80. So what is 60% times 80? Is that 48? 48, right? Then you look for the position number 48. And we see that it is 58. So that's all. Okay, good. So you see our interquartile range, right? The median and the percentile, always tested. By now you would have done many of such questions already, so no reason for you to still cannot do it, because it will be tested. $58. Then you have to check your reading. Alright, next one. 160 competitors. Bicycle race. Median position. That is 50% times 160, that is 80. So search for the 80. We have 17.5. That's part A. Part B, interquartile range again. Lower quartile position. 25%. 160. 40. So lower quartile, 15 minutes. Upper quartile position, 75%, 160. So we have 120. Upper quartile, 120. 20.5. So interquartile range. Okay, that's part B for the interquartile range. You see that the steps are always the same. No reason to not be able to do it. Now part 3. Number of competitors took more than 13 minutes. More than 13 minutes. Definitely I need to go to the graph and find 13 minutes. 13, 10, 11, 12, 13 over here. Here we have 25 square represent 20. 4 square represent 16. So 16. I've got 16 people who took 13 minutes or less. 16 people took 30 minutes or less. Since they want more than 13 minutes, then part 3, number of people will be our 160 minus 16. 144 people. 144 of them took more than 13 minutes. So now fill in the rest of the blanks. Less than or equal to 20 minutes. Minus 116. Less than 25. One square is 4. So this is 140, 146. Less than 30. 160. Okay, do you get the same values?
Yeah.
Okay, check our work. These are just readings from the graph only. Sorry? Why not leh? It is all reading from the graph, ma. It is accumulative. You're not supposed to subtract. Okay, last question. Before we move on to other things. I think we talked about part B already. Part B was already done. So let's check our answers for part A. Part A, find the interquartile range for paper 1. So this is our paper 1. I'm not interested in paper 2. So paper 1, interquartile range. Lower quartile position for paper 1. That will be 25% times 40. That's 10. So the lower quartile equals to, at position number 10, cannot see clearly. Is it 52? Is it 52? This part A you can do. Upper quartile position.
Because the paper one is like.
Paper 1?
It's not 0.
Doesn't matter. The lowest score is actually 10.
Oh.
So lower quartile position, the upper quartile position will be ours, 75% times 40. So that's 30. Yeah. So that is 76. So interquartile range, 76 minus 52, 24 marks. That's it. Just reading only, ma. We will use median. So this is a performance question. Use median. Okay, can you all write this down? This is the the key point over here. Which one is more difficult? It is on performance. So you use the median to compare. Kaiser, have you written it down? This is on performance. So you must use the median, not the interquartile range. So now we are going to compare the two medians. Okay, median in paper 1, median in paper 2. And this is going to be the format. Okay, quite clearly the median position is 20. So this is median for paper 2, and this is the median for paper 1. Their values are, paper 1 we have 68 marks. Whereas in paper 2, it looks like 33 marks. Okay, so this is the format, median. Then you write at the bottom. All of you write it this way, median. Then at the bottom, paper 1. This is short form. Short form for what? Short form for writing the median of paper 1. So we compress all that, combine to become median, and then you write at the bottom, paper 1. What is the value? You open bracket. So instead of saying the median of paper 1 is how much? We shorten it further. Median paper 1, 68 marks. We want to say that this is greater than the other median. But I'm too lazy to write so many words. So I use this symbol, greater than. The median for paper 1, which is 68 marks, is greater than the median for paper 2, which is 33 marks. Okay, so here I have in one line said a lot of things. I have the information, the median in paper 1, which is 68 marks, is greater than the median in paper 2, which is 33 marks. So based on this information, which one more difficult? The higher mark more difficult or the lower mark more difficult? Lower mark more difficult. So now you can conclude to say that, therefore, paper 2 is more difficult. This is our conclusion.